appreciate that. Our next speaker is Dr. Sharon Goldberg, who's product director at Cloudflare. But I was looking you up, and you're very interesting. You know, you are a professor at Boston University, but even more interesting, you sold Bastion Zero a year ago, and you're an entrepreneur, and you had a nice exit. So thank you.
Okay, good morning, everyone. I'm really happy to be here. This is my first time at a quantum cryptography conference, so it's a real pleasure to be here and be doing this conversation with you guys. So I am one of the product managers that lead productization of post-quantum cryptography at Cloudflare. I've been doing this since February. As mentioned, I sold my company to Cloudflare last year, which was a cryptography startup, and then they released me into the organization, and one of the things I picked up was post-quantum cryptography. So I'm going to share with you a lot of the really amazing things that we've done at Cloudflare. I actually didn't do most of them. My colleagues did a lot of them, but I'm continuing to push this roadmap along. And I wanted to share with you just how we're thinking about post-quantum cryptography and how we're thinking about meeting this deadline, which in my mind is 2030. And the reason that's the deadline in my mind is that's the date that NIST said we need to deprecate RSA and ECDSA and all asymmetric cryptography that's used everywhere. So in my mental model, 2030 is the day. Depending on where you are, you may have a different mental model, but that's kind of what I'm thinking about. So just a quick introduction about what Cloudflare is. So we basically build a bunch of products on a global network that we have developed and owned. We have points of presence in 335 cities. About 20% of web properties are hosted behind Cloudflare. They're using Cloudflare as the CDN or as their application security provider. So a lot of websites are behind Cloudflare. You've probably seen that little thing with the CAPTCHA test, which has Cloudflare and the little check mark. That's one of our many products that runs on our network. So that's where you will see Cloudflare, but we also have a whole bunch of other products. We have a developer platform where you can build AI. We have our SASE platform, which is actually my home, where you can use to build your enterprise networks using Cloudflare. So all of these different technologies through our networks. And one of the really cool things that happened was, I think it was 2018 or 2019, Cloudflare decided they were going to go all in on post-quantum cryptography. We have a number of cryptographers working at Cloudflare. Almost every one of them works on post-quantum cryptography. That's been a real focus for the team. We started building post-quantum cryptography in 2019 before the standards were ready, before they were called ML-KIM, which you heard mentioned previously. So it was called back then CEC-PQ2. And so we were doing trials between laptops, like your laptop running a web browser, talking to Cloudflare's network in order to access a website that's behind Cloudflare. So that was started in 2019. That link between your web browser and the Cloudflare network was turned on with post-quantum cryptography in 2022. And this is a chart that showed, I pulled this a couple days ago. It shows the fraction of traffic that's post-quantum on Cloudflare. That 31.9 is the average over the last year. It's actually 39% right now of the traffic that goes from a web browser to Cloudflare's network is actually speaking post-quantum cryptography. I'm going to talk a little bit about what that actually means and what the cryptography is, because I want to be really clear on what that is. But I just wanted to mention that we are doing this at scale. We are doing this with regular devices, your commercial laptop, no special hardware. We don't use any kind of special technology here beyond lattice-based cryptography, which is post-quantum. Just to note, lattice-based cryptography runs on regular computers. You don't need a quantum computer, any kind of specialized hardware, any specialized connectivity. It just runs on regular computers. And that is obviously very important for us because we turn this on. Most people don't even know that it's on. There's no setting you set. We just turn it on and it works. And that's been really important for being able to operate this at scale. So since 2022, we've been running this to our network. We have a massive initiative across the company to turn on post-quantum cryptography on our internal links and all our products. And so I'm going to talk to you about some of how we've done that. But really what I think what I hope to share with you today, because I know this is a massive initiative for everyone in this room, is how we've approached it and how we want to sort of share our experiences with the community on how to manage your own upgrades when you're thinking about this. So just to go over what I was describing before, so we have a clear picture about what this technology is. When I connect with my web browser to a website that's behind Cloudflare, so if we look at the edges of the diagram, the web browser, and on the other side we have some sort of web server that's serving us the website. If that web server is behind Cloudflare, we can connect it to the Cloudflare network using a technology we call Cloudflare Tunnel, which is just a server agent you run on the web server. That connection, which is labeled 3, speaks post-quantum cryptography, and they actually upgraded it in 2022, in fact. One of the reasons we did this in 2022 is because we owned both sides of the connection. We own the server agent and we own the edge of the network, so we upgraded both sides without really any standards, like any need for cooperation with any third parties. So that's been post-quantum for a long time. And then when I mentioned our partnership with Chrome, a lot of web browsers now will initiate connections using post-quantum cryptography. And so we are able to receive those connections and negotiate a post-quantum connection. I'm also a cryptography professor, as was mentioned, so I just want to spend like 1 second on how this works. When the browser initiates the connection, it advertises that it speaks post-quantum cryptography amongst other algorithms. If the server supports post-quantum cryptography, it will advertise which subset of those algorithms it also speaks. And if both sides speak post-quantum cryptography, they will negotiate a post-quantum connection. That's how we make this interoperable, right? If the client doesn't advertise post-quantum to us, we'll speak classical crypto. If the client does, we'll speak post-quantum, because we can see when they negotiate. That's why we're at that 39%, right? So 39% of web browsers will initiate the connection to us in a post-quantum way. Okay, so TLS, which is the most, arguably the most important protocol for encrypting the internet, has all these mechanisms built in. TLS has been working on post-quantum standards for 5 years, probably longer, I'm not even sure. But it's all very, very well understood at this point, and it is running at scale, right? So I just want to mention, and actually you're probably wondering about the performance hit. So do we know that TLS was recently upgraded from 1.2 to 1.3? Yeah, so it turns out that the efficiency upgrades from 1.2 to 1.3 actually mask any performance hit that you would have with post-quantum. So in fact, 1.3 post-quantum is more performant than 1.2 without post-quantum. So there's very little incentive to not do this from a performance perspective if you can do it. So I just wanted to put that out there. There are a lot of challenges with post-quantum cryptography, but figuring out how to do post-quantum TLS is not one of them anymore. Okay, this is just a matter of upgrading those algorithms. Okay, so we are here in 2025. That's 4.5 years before the deadline in my mind, which is 2030. And I want to talk about how we're thinking about deploying post-quantum cryptography at scale today. And I'm going to, again, I said I'm a crypto professor, so I'm going to do some crypto professing for you. Hopefully, this will be helpful for you as you're thinking about this in your organization. Do we know the Diffie-Hellman? Have we heard of Diffie-Hellman key exchange? Okay. Does Diffie-Hellman key exchange survive cryptographically relevant post-quantum computers? No. It's dead, okay? We cannot use Diffie-Hellman once we have cryptographically relevant post-quantum computers. That is what's starting all of our problems. We cannot use Diffie-Hellman as is anymore. What Diffie-Hellman does is it allows, imagine this is the client and I'm the server. It allows the client and the server to use public key cryptography to agree on a shared key, shared symmetric key, that's used to encrypt their communications. Okay, so they use it for key agreement. Now we have a symmetric key that I know and the chair knows, and we can encrypt our data. That's what Diffie-Hellman does. Okay, so that breaks down in the face of post-quantum, in the face of cryptography, cryptographically relevant quantum computers. A simpler way to say that is when Q-Day happens, Diffie-Hellman is broken. The very first thing that the speakers previous to me said was, harvest now, decrypt later attacks are a problem. A harvest now, decrypt later attack is when an adversary just watches the communication, stores it in its recording devices, and then after Q-Day, decrypts it all, right? So Diffie-Hellman is vulnerable to harvest now, decrypt later attacks today, right? So if someone takes my Diffie-Hellman key exchange and it stores it, they can use a quantum computer in the future to crack it, learn the secret key, and then decrypt everything that we did, Okay, so we have to upgrade Diffie-Hellman now if we are worried about harvest now, decrypt later attacks. How do we upgrade Diffie-Hellman now? It's this algorithm called MLKIM. Okay, that's what we need to use. So MLKIM is the replacement for Diffie-Hellman. It allows you to do key exchange that's robust to quantum adversaries. Okay, that's the end of the crypto lesson. Now let's talk about what we actually need to do here, practically speaking. TLS today, when we say post-quantum TLS, we're saying TLS with MLKIM, that's running MLKIM. It's running it in what's called a hybrid mode, at least in most scale deployments today. Hybrid mode means we have our new post-quantum algorithm running in parallel with the classical algorithm. Why are we doing that? Because some people, basically we get the security of both. If the quantum computers are, if the classical algorithm is secure, we get the security from that one. If the post-quantum one is secure, we get the security from that one. Running them in parallel gives us extra assurance in case there's issues with the post-quantum algorithm. We don't believe there's issues with the post-quantum algorithm, but this is just a conservative way of doing things. And so that's how majority of these deployments look. This is called a hybrid deployment. And so that is what TLS is, and generally on the public internet, anything that's really interoperable, that's what people are doing, and that is what they should be doing today. The cool thing about this is that, so again, it reduces security and compliance risk. The cool thing about this is that hybrid MLKIM will run on regular hardware. Maybe embedded devices struggle. So if you're running an embedded device that can barely do elliptic curve cryptography, then ignore what I'm saying. But for generally like computers that we use in phones and regular things like this, you can run MLKIM without too much of a problem. And so that's where our focus is, because we want to be able to serve the whole internet. There is a technology called quantum key distribution. I'm sure we're going to hear about it today. We actually do not do that at Cloudflare. Quantum key distribution is when you use a specific, basically hardware technology to negotiate those keys. So it's another replacement for Diffie-Hellman, but now you're using some sort of technology that you are running either on your machine, or you need maybe a vacuum connection or a photonic connection between those two endpoints in order to communicate with QKD. So there are hardware requirements there. And so we don't do this because we don't want to deal with any hardware requirements that are specialized, because we don't know what hardware our customers are running. We just want to support everything. So we go with post-quantum cryptography and not with QKD. Another thing that we think is really important for the community, and I don't know how much relevant this is for this, so I'll quickly go over this. We work a lot with standard bodies. We believe a lot in standards. We encourage people to use standards and to participate in standardization processes. And so that's what we do. I wouldn't want to kind of go to customers and say, which crypto algorithm would you like to use? Would you like to choose this one or that one? We don't provide a menu of crypto algorithms. Our approach is to turn it on by default, not make a lot of noise about it, and just have it there so that people don't have to think about it. The whole idea of a menu is very scary if you're someone with a long history in cryptography and you've seen all these attacks that use, old algorithms and whatever. So not good. We don't like that. Last thing I wanted to say, this is the most important thing. The previous talk was mentioning crypto agility. Crypto agility means the ability to upgrade from one cryptographic algorithm to another. It's such a nice word, but it's so hard. It's so hard. I wrote a paper last year attacking MD5, which was deprecated in 2004. I wrote a paper about it in 2024, 20 years later. Crypto agility is very, very hard, right? So what we're doing and the way we're thinking about this is we would like to provide the internet with tunnels that you can tunnel your traffic through, and the tunnel will have a post-quantum protection around it, and you can just shove whatever it is you want through that tunnel. And it will get the protection from the tunnel. And so the idea is, I have a slide. The idea is, for example, this is our zero trust platform. This is like a VPN replacement. You would use your laptop and put a client on it, and that would be able to connect you into your office, which would be running our server agent, which you can see in the corner. We have a whole platform for VPN replacement or secure access service edge, SASE. Has all the names, SSE, SASE, Zero Trust, VPN replacement, all those things. That's our Cloudflare One platform. We are working on making this post-quantum. All the TLS connections are already post-quantum. And so the thinking here is, for example, if you have a whole bunch of machines in your data center and a whole bunch of employees that need to connect into those machines, it's very hard to think about upgrading each individual service in all your data centers to be post-quantum. You may have like RDP technology, you may have SSH, and you may have lots of web servers, and who knows what you have in there. Trying to upgrade every one of those systems is really, really hard. And while we will have to do it, it's probably not the thing we should do first, right? The first thing we should do is try to figure out how to make sure that when those machines leave the data center, they're speaking over a post-quantum connection over the public internet. And so that's where post-quantum tunnels come in. So that's really what we're thinking about, and that's how we're sort of encouraging people to think about upgrade. Where can you put a tunnel where you shove all these different protocols and all these different technologies through the tunnel so that they're protected while they go in the tunnel and while they go over the public internet? That's the type of technology that we're providing to our customers, and that's, I think, what I would encourage you to look for in vendors. I wouldn't worry so much at the first phase about, like, is this particular server post-quantum right now? If you're buying a new server, certainly try to make it post-quantum, but trying to like retrofit it onto older things is much more difficult than trying to put a tunnel in place that collects all the traffic from all these devices and then provides a post-quantum protection to it as it goes over the internet. So that's what we're trying to do for customers. Okay, so this is our Zero Trust platform. I just wanted to mention, if you use our device client, it would be post-quantum. If you use our clientless version, it's also post-quantum. And then we have other stuff. But what I really want to talk about is more about crypto agility. So what I just described was sort of what we need to do today. I only talked about ML-KIM. If you were listening carefully to the previous talk, there was a mention of ML-DSA. Do we know what ML-DSA does? What's the difference? Signatures, right? So I was talking about upgrading Diffie-Hellman, which is the key exchange. I hadn't mentioned signatures. I hadn't mentioned certificates. So if we know TLS uses certificates. Certificates have digital signatures on them. Those signatures are usually RSA or ECDSA, right? RSA, ECDSA broken by quantum computers, okay? The good thing is that RSA and ECDSA, those signatures protect us against active adversaries. So if I'm creating a TLS connection with the chair, if someone wants to, if someone has an ability to break signatures, they can actively attack my connection. But if I have ML-KIM here, they can't do a harvest now, decrypt later attack. So basically, I didn't explain that well, let me try again. If you deploy ML-KIM, you are protected against harvest now, decrypt later attacks, if you only deploy that. In the future, you need to deploy secure post-quantum signatures, because in the future, if you have an active adversary, that adversary would be able to break your connection unless you have those post-quantum signatures. So in other words, this is only needed after Q-Day and not before. Okay? So digital signatures are not required for security before Q-Day, but they are required after. The problem is, like everybody said, we don't know when Q-Day is. So we do need to figure out how to do digital signatures because A, we don't know when Q-Day is. We also know that crypto upgrades are really hard and they take a lot of time, right? So even if you today have bought a product from a vendor that is quote unquote post-quantum, most likely it is ML-KIM and not the signatures. So it is important to think about how you're going to see this crypto agility from your vendor over time. We need to be careful that we're not buying something that has ML-KIM and calling it a day and being like, we're done, we don't need to upgrade the signatures. So as vendors, we need to be thinking about, speaking from like the vendor side, we need to be thinking about how are we going to do the ML-KIM upgrade for today, and how are we going to be able to easily upgrade our customers to signatures next. Okay, so vendors need to be thinking about doing that, and that's one of the things that we are doing at Cloudflare. So it's almost like I would encourage people and vendors generally to just think about being the crypto agility solution for their customers, right? We're selling you post-quantum. There needs to be agility. We're selling you ML-KIM right now, but in the future, we're going to sell you signatures. What is the path for making that upgrade? Do you have a plan? We do have a plan, right? And so it's important to make sure that vendors are doing that. Right, and so I guess just the last thing I would say is like thinking about this in stages. Let me see if I have a slide. I don't. Thinking about this in stages, let me just give you a couple of suggestions. I didn't make the slide for this, but I think it's important for this audience. Where we are today, you'll often hear people telling you to do crypto inventories. I think that's good. I think that's fine. But I think when you're doing the inventory, I would worry less about upgrading every single device, right? If you've got an upgrade cycle coming, excellent, great. But I think I would worry more about how do I create those tunnels and how do I make sure that I can put traffic inside a tunnel which is protected with post-quantum. That's the phase one. Then actually do the upgrade to the post-quantum connection and make sure that the way you're doing that is going to actually have the crypto agility to also give you not just key exchange with ML-KIM, but also digital signatures. So we need to make sure that our vendors are sort of like explaining to us how are we going to get this crypto agility going forward. Okay, and then I would say once we move out of the world of tunnels, then it's really the time to go one by one through these individual services and figure out how to upgrade each individual service, because we do have if you build a data center, you have TLS between services in the data center. That is the standard for security today. We are going to need those TLS connections to be post-quantum, but it may not be required to be like the very, very first thing that you do when you're thinking about your migration. So I would really encourage you to think about tunneling as an initial strategy for this, tunneling with crypto agility sort of built in. And then I'm talking really mostly about sort of like data center, enterprise networks, and public-facing networks. If you're in the OT and embedded space, that's a totally different space. But sort of for the less complicated, less hardware-heavy spaces, this is the strategy that we are encouraging our customers to do. So yeah, that's what I wanted to share. I don't know how much more time I have. 0. So thank you very much for having me. I'm going to be in the back corner if you want to chat more with me or my colleagues about our plans for post-quantum. Thank you.